So if I have a question like this, x to the second, x to the third, what do? You add what? The exponents. Good. So the first thing you want to do is keep the base, add the exponent. Okay, so what would the answer be to that? Yes? X to the fifth. Good. You just add the exponents, keep the base the same. Good. What if it was something like 2y to the third times 4y to the seventh? Then what? Yes?
You would still add them, right?
You still add the what? Which part?
The exponent.
The exponents. Good. So that'd be y to the 10th. Good. And then what do you do with the coefficients? You just multiply those like regular. Okay? Any questions? Okay, next is where you take a power to a power. So if you had something like x to the third to the second, or something like 2x to the fourth, y to the third, what do we do on those? What? Good. We keep the bases the same, and you multiply the exponents. So what would the answer be to the x to the third to the second? X to the sixth. Good. What happens when you have a coefficient? You still keep the base the same. You still multiply the exponents. Just don't forget that there's an exponent of 1 there. So this is like 2 to the third because of the exponent 1 times 3. Then x to the 12th, y to the 9th. Now, you can't leave your answer like this because we actually know what this is. What is that? 8. So if you can actually multiply it out, do it. Okay?
Wait.
2 to the third, you can actually do 2 to the third. It's just 2 times 2 times 2. So you want to do it. If you forget on your quiz, I'll just circle it and put like simplify or
Okay.
evaluate.
I know what x was, and I was really confused.
Nope, we do not. Yes, ma'am.
Do we have to show the step of 2 times 3 or can we just do it?
You can just do it. Yeah, if you could just do 2 to the third in your head, go for it. All right, dividing like bases. So that would be something like x to the fifth over x to the second. Or we could also do like 4y to the second over 2y to the seventh. Yep. Good. You subtract the exponents. Right, and write it wherever the bigger exponent was. So how can we write that? We'll just put right answer. Where the larger exponent started. Does that make sense? So part A, x to the fifth over x squared. Where's the larger exponent? On top. So our answer will go on top. And what would our new exponent be? 3. Good. Do we need a bottom? No, because the only thing left on the bottom would be the placeholder of 1. So we're looking at the exponents, 5 and 2. 5's bigger, so our leftovers will go on the top, and then you just subtract the exponents. All right, on part B, these are just regular old numbers. What's regular old 4 over regular old 2? 2, and that would go on the top, right? It's like 2 over 1. Where are our leftover y's going to end up? On the bottom. So I will have a top and I will have a bottom. What goes in our denominator? Y to the 5th. Very good. So the 2's in our numerator. It does simplify to be a whole number, 4 over 2. And we know whole numbers go in the numerator over 1. We don't need a 1 because we have the placeholder in the bottom already, the y to the 5th. So we're good to go. Questions? Those are kind of the tricky ones. Yes?
Can you explain the last one?
Yes. So I did the coefficients first. So you could even do the ABC button if you needed to on your calculator. So what is 4 divided by 2? 2. Kind of like 2 over 1, right? So if you wanted to put 2 over 1, you could. I'll put it there for a second. And then look at your y's. Y to the 2nd over y to the 7th. Which one's bigger, 7 or 2? So my leftovers are going to go where the 7 started, which was the bottom. So technically in the back, we have 1 over y to the 5th. But we don't need the 1's right now because we have an actual number in the numerator and we have a variable and an exponent in the denominator. So you don't need those placeholders. You can just put the 2 in the top and the y to the 5th in your denominator. Questions? Okay. This is the last one that we know so far. I'll give you 3 real quick examples. What are all of those?
0.
Somebody whispered it. Anything to the 0 power is?
0.
No.
1.
1. That's the rule. Anything to the 0 power. That's a weird, sorry. Is 1.
No.
So what's x to the 0 power?
1.
What's 5 to the 0 power? What's 3x to the 10th, y to the 15th to the 0 power? 1.
Can our test just be 0 exponents?
No.
So then we have all the pieces.
All right, any questions? So what's going to happen now is we are going to go through a few review questions on the board. So you need a blank sheet of paper. If you don't have any blank sheets of paper, I have scratch paper up here. So number 1 is on the board. You need to follow the order of operations, evaluate this. All right, so what is negative 3 to the 2nd power? Negative 3 to the 2nd power is like negative 3 times negative 3, which is positive 9. Plus, in parentheses, what is negative 4 to the 2nd power, not in parentheses? Negative 16. There are no parentheses around that negative 4. That's negative 4 times 4. Okay? Same thing in the back. That's negative 2 times 2 times 2. Negative 8. Good. Now, still working in those parentheses, what is negative 16 minus 8?
8, positive 8.
They're both negative, so add them and keep the negative sign. Negative 24.
I thought since they're both negatives and 8 are positive.
That's only when you're multiplying or dividing.
Oh gosh, this is so...
This is the time where if you're still struggling with adding and subtracting, start relying on your calculator a little more heavily. You don't want to be missing these types of questions because you're confused about signs. Just trust the calculator.
There's just so many rules.
I know. What is positive 9 plus negative 24? Negative 15. Good. So number 2 says, what's the degree of this term? How do I find the degree? Add the exponents. So 3 plus 4 plus 1, that we don't see, that's with the z. So what would the degree of this term be? 8. Number 3, what's the degree of the polynomial? So how do I find the degree of the polynomial?
What's the polynomial again?
The whole thing.
Okay.
Yep.
Like, how do you do it or what it is?
How do I do it, or what is it?
It's the degree of the largest term.
Right, it's the degree of the largest term. So you want to go through and find the degree, and the degree is the total exponents. So the degree of this term would be 5. The degree of this term would be 1 and 1, which is 2. The degree of this term would be 6, and the degree of this term would be 1. So what's the degree of the polynomial? 6. It's the largest degree. Good. All right, number 4 says write in descending order with respect to the power of x. So what that means in easy terms is the biggest exponent of x to the smallest exponent of x. Descending order means start at the biggest, go down. So I'll give you a second. Give this one a shot on yours, and then we'll see how you did.
Wait, you said biggest to smallest?
Biggest to smallest x exponent. So what's the biggest x exponent? Yes, ma'am. 2x to the 7th will go on the front. Then which one? Right, minus 3x to the 5th, y to the 2nd. Then the minus 7x to the 3rd, y. And then the plus the 6x. Good. So how would I add these two binomials? Yes, ma'am.
Do whatever you like.
Yeah, you basically just combine like terms when you're adding polynomials. So what's 4a plus 3a? 7a. And then negative 5 plus 6. The signs are different, so you subtract the numbers, keep the sign of the larger number. You get a positive 1, which we write as plus 1. Questions? Yes, ma'am?
What is this for? Polynomial?
We're adding polynomials, yep. All right, here's one where we subtract the polynomials. How do you subtract a polynomial? What do I have to do first? Yeah, before you combine any like terms, you need to distribute the minus. So this is actually going to be minus 5x minus 2x squared. Then you can combine the like terms. So you'll have a negative 1x squared minus 2x squared. That's how we get negative 3x squared. And then 3x minus 5x is negative 2x. Any questions? All right, here's number 7. Same idea. You need to write out a step in the middle where you distribute the negative sign. Okay? So rewrite the first one as is, x to the third minus 3x plus 7. Then we'll distribute this. So minus 10 plus 4x to the third minus 12x. Okay, so what is x to the third plus 4x to the third? Yes?
5x.
So we'll start with 5x to the third. Do I have anything that goes with the 3? Yeah, so negative 3x and the negative 12x would be negative 15x. And then we have 7 minus 10, which would be, yeah, so this is what you should end up with. Any questions? Yep, we have like bases, so we keep the base the same. We add the exponents. This is x to the 10. Sorry, a to the 10. You know what I meant.
Did we?
I hope so. All right, next. Same idea, just some more variables. What do I do with the coefficients? Multiply them. What's 2 times 7 times 2?
24. Or 28.
28. Good. So I have 28, and then x to the third, because I have 2 and 1. Good. And y to the 7th, because I have 3 and 4. Very good. All right, what are you guys coming up with? Hold on. X to the... Wait, what did you come up with in the front? What's your new coefficient? Negative 18. Good. We do 3 times negative 6. And then x to the third, y to the 9th, z to the second. Beautiful. Questions? 21. Oh my. That sigh was out loud. All right. We can pick up the pace a little if you guys are getting bored on me. What is 1/2 times 2/3? Well, multiply the top, the numerators. Yeah, you'd end up with 2/6, which is 1/3. Good. And then same thing with the exponents. Add the exponents. X to the third, x to the first is x to the fourth. Y to the first, y to the first is y to the second. All right, here's number 12. So we have an exponent to an exponent. There's one base with 2 exponents. What do I do in this case? This is when you multiply the exponents. So boom, m to the 12th. All right, number 13. Careful on this one. The parentheses have exponents on the outside. I'm actually going to write out a middle step here before the answer magically pops up. What is 3k to the second?
9k.
9k to the second. Good. In the back, what's 3k to the fourth? Can you see that to the fourth?
Yeah.
Let me squeeze it over. Okay. That's the middle step because the answer will magically pop up and I want you to know where it came from. Okay, so we have to take the 3K in the front to the second, the 3K in the back to the fourth. Wait a second. I could have skipped a step, but we're good. We're good. We'll go with that. Boom. The alternative way, once I noticed that the bases were the same, you could actually make this 3K to the 6th and then go from there. So you'd take 3 to the 6th, still give you 729K to the 6th. So it doesn't really matter your approach.
Wait, how did you
They both work. So see how they're both 3K? So you could, since they have the same base, you could have added the exponents and then done 3 to the 6th, K to the 6th. But 3 to the 6th is 729, so you get the same thing.
But I messed up.
All right, here's number 14. What's 2 to the 3rd? Good, 8, and then you you multiply all the other exponents. So 5 times 3 is 15, 7 times 3 is the 21, and 3 times 3 gives you the 9. This is the one in your notes at the beginning of the lesson we wrote out like 2 to the 3rd, and someone said, do we actually need that step? And I said, not really. 3 to the 3rd is 27, 2 to the 3rd is 8. Yes, ma'am.
Wait, on that one, do you have to take like 3 times 2 and 3 times 5 and 3 times?
Not 3 times 2. 3 times the 1, that's the exponent with the 2.
Oh.
You do each. But I didn't write that step out because 2 to the 3rd is something I can just do pretty quickly.
So you distribute the 3 to the exponents, not the bases?
Yes. All right, this is what I'm going to write out. So order of operations, we have to do multiply, multiply. So what do we get up front? What's 6b to the 4th times negative 3b squared? Negative 18b to the 6th. Good. Plus, what do I end up with in the back? Yeah. So negative 2 times negative 1 is positive 2. And then b to the 1st and b to the 5th. When you multiply those, you add the exponents to get b to the 6th. Now, what is so special about these two right now? They're the same. They're like terms. So you can add or subtract the coefficients. In this case, we're adding them. We get negative 16b to the 6th. Yes?
So what would happen if you got like...
If they weren't like
same,
terms?
Yeah.
If they're not like terms, you just leave it alone.
B to the 6th and B to the 8th.
Right. Then you just leave it with a plus sign in the middle. That would be the answer. All right, number 16 for our little review lesson is x to the 5th over x to the 2nd. You get x to the 3rd. Good. You just subtract the exponents, and we started with more x's in the top, so our leftovers go in the top over 1, so you don't really need the over 1. There you go.
Why don't you just write x to the 5th minus x to the 2nd?
What?
Why don't you write x to the 5th minus x to the 2nd? And that's basically
No, you're doing x to the
Yeah,
5th.
this is not the same thing as x to the 5th minus x to the 5th. Hold on. Back it up. The question was, why don't I write this? That's not the same thing. There I would need like terms to combine them. I don't have like terms, so that does not simplify. So don't get confused. That's not the same thing. All right, on the next one, number 17, we have a to the third over a to the seventh. Same idea. You want to subtract the exponents. We'll get a to the fourth, but what's different about this one? It goes on the bottom. Yeah, this goes in our denominators. And then we need a numerator placeholder of 1. All right, number 18. Ideas? Yes, ma'am? Okay, and what about the 3 and the 6? Okay, good. So with our coefficients, we end up with 1/2. The g leftovers go on the top. So now since you have something in your numerator, you don't really need the 1. And then your d leftovers go in your denominator. So this is what we end up with. All right, and then last one on this slide is number 19. We still have one more slide with 2 examples, I believe. Mm-hmm. And then you have a review. All right, so this is one where I would, again, just think back to order of operations. Anytime you have something in parentheses that you can simplify, that's where you want to start. So nothing happens to that 2. What about the x over x squared?
X on the bottom.
Yeah, you get x to the first in your denominator, which is just x. Good. What about the y's?
Y to the second on the top.
Yeah, y to the second in your numerator, and then that's all still to the second. Now you can take all the exponents and multiply them by 2. So we get 2 to the second, but what's 2 to the second? 4. And then y to the
First. Oh, wait.
second to the second is
Y to the fourth.
4th. Good. And then on the bottom we get x to the
First.
second, because you have to you're multiplying all the exponents by 2.
do this.
Will you get the same answer if you distribute 2?
Yeah, if you did it the other way, you get 4 x squared y to the 6th over x to the 4th y to the 2nd. And then you should end up in the same spot. Yep. Still works. Questions? Oh, there's a magical answer that pops up. All right, here's number 20. Okay, I am going to write this one out as well. So what I can do is do 12 to the 3rd, x to the 12th, y to the 15th, over 12 to the 5th, x to the 15th, y to the 5th, right? 1 times 5. Okay, take it piece by piece. Do you see how the 12s have the same base? And I don't want to sit here and do 12 times 12 times 12 times 12 times 12 if I don't have to. So since I noticed that they have the same base, I'm just going to subtract the exponents. So that would give me 12 to the second, and that's going to go in our denominator. Good. Next, I'll do the x's. That gives me x to the 3rd, also in the denominator. Good. And y to the 10th. That will go in the numerator. Now, there's just one more thing you need to do, though. You don't want to leave it 12 to the second. How would we write it? 12 times 12, which is what? 144. Good. All right, here's our final review question of the day. And then I'll give you some independent review time. We want to find the area and the perimeter. How do you find area? Yeah, so area is length times width. So in this case, it would be 3x to the third times 3x, which is 9x to the fourth. Good. You got to add the 3 and the 1. All right, how do I find perimeter? Perimeter is 2L times 2W. So 2 and 2. So for perimeter, I have 6x to the third plus 6x. Can I add those? No, we have x to the thirds, we have x's. Those do not combine, they're not like terms, so this is my perimeter. That's as simple as it's going to get. Any questions? So I am going to give you review day 6. I'm also going to give you the answers for review day 6. As you go through the questions, check yourself. If you can't do the review and get the right answers, I'm not sure how you're going to expect to do well on the quiz tomorrow, okay? So options for those who are struggling is a pass to tutoring. You can go to the math office after school until 4. You can show up before school in the math office at 8. I will try to be here around like 8:05, 8:10-ish up in the math office as well. So if you need me personally, I'll be available as well. Questions?